Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Right now we are in our lecture number 4, and I understand that we are a bit late. So now I will be just picking up, inshallah, and will be uploading videos more quickly. So you have to just also start working hard. In this lecture number 4, what I will be just covering is I will be just giving you a little bit practice of RC and RL step response problem practice. So these are the problems that I will be covering in this video. So starting from practice problem 7.11, then practice problem 7.12, then I will also be explaining example 7.13, which is already explained in your book, already solved in your book, but I will just go through it, and then I will solve 7.13, which is a very important exercise, and then I will also be doing an end of the chapter problem 7.65. So I will just try to wrap it up in less than 20 minutes. So sometimes maybe I will just skip over the simple steps that you will have to just do it on your own. These will be just simple algebraic manipulations. I will be just explaining the concept, and then you can just do the manual calculation, and it's already in front of you in the form of solved example or solved practice problem. So before just going any further, I will just say that in this current circumstances where everything is locked down and everybody is worried, so we should be just focusing more on making Allah subhanahu wa ta'ala more happy. So you will all be means for focusing on this thing, and will be regular in your prayers, inshallah. So please be regular in your prayers in salah 5 times a day. Allah subhanahu wa ta'ala, Huzur sallallahu alaihi wasallam said that Allah subhanahu wa ta'ala has said that मैंने आपकी उम्मत पर 5 नमाज़ें फ़र्ज़ की हैं, और जो इसको अपने वक्त अदा करने का एहतमाम करेगा उसको मैं अपनी ज़िम्मेदारी पे जन्नत में दाखिल करूँगा. Alright, so starting our lecture now with the name of Allah, the most merciful and most beneficent. Bismillahirrahmanirrahim. So this is the step response of RC circuit, and we already have gone through it in our video number 2. In video number 3 we had practice for natural response, and now we are practicing for step response. Alright, so what equation is important? This is the complete response, and it can be just divided into two type of classifications, that is natural response and transient response. What was that? Our natural response and forced response. So this is the response. Natural response is on the part which is in the bracket, and due to this exponential, this is going to be going to die out, and this is going to remain as a complete response. So the complete response definitely will be addition of these two things, but this is transient response, and this is going to be transient response, and this is will be the forced response. Okay, sorry. So this is going to be forced response, this plus this, because this is Vs is involved, but this is going to be the natural response. Alright. One more classification is transient response and steady state response. So transient response is something which is with the exponential in the bracket, and steady state response is the response that will just keep going on after the transient response has died out. So just going through it, these steps, that is the steady state response is given by this, and the transient response is by the bracket term which is in the with the exponential. So keeping it simple, we can just divide it, write in this form, that Vs is going to be the response, that is the voltage of the capacitor that will just remain there due to the excitation or due to the supplies, and this is the initial voltage, and this is again the V infinite. So we will just find it out, these things, so solve the problem. So this is the key for working: the initial capacitor voltage, the final capacitor voltage, and the time constant is to be found out. Time constant will be found out by RC, and R will be considered as the R Thevenin on the terminals of the capacitor. So this is the problem which we already have done. I will start with practice problem 7.11. Going with more, and here we are, and we are just doing, let me check, we are recording. Yes, we are recording. Right, so the switch in figure, what they are asking for, they are asking for to find out the response of this capacitor. This supply is 2u minus t. 2u minus t means this is a function which is 1 before less than time t is equal to 0, and after time t is equal to 0 it is just not there. So it will be cut off after time t is equal to 0, and this switch will go on after time t is equal to 0. That means after time t is equal to 0, after this supply will come in action, but before it this is just not there, not here. The only supply at time t is equal to less than 0 is 20 volts. So I will just show you the solution here. So this is the circuit after for time t is equal to less than 0, because 20 volt supply is there. 20 u minus t means 20 for time t is equal to less than 0 and equal to 0 for time t greater than 0. I will just zoom it for you so that you can have it a bit more clear. Okay, so here you are. So this supply is connected with the the capacitor through a resistor, so it will go to 20 volts, because it is connected with the this capacitor for a very long time before time t is equal to 0. So this voltage will go to, the voltage of the capacitor will go to 20 volts, and when the capacitor is fully charged, the I will be 0. So a capacitor voltage cannot change suddenly, so that's why this will just remain 0. This will just remain 20. The circuit for time t greater than 0 is that this supply has been shorted out, because it was a t of u minus t. It was 20 u minus t, this one. So this has been shorted out here. From here the capacitor is already there at its place, and this switch, there was a switch here, has gone on. So this section gets connected to the capacitor. So after a long time t is equal to 0, circuit reaches a steady state, and capacitor functions like an open circuit. So this will be considered open circuit. Now what we have to do is we have to find out the capacitor voltage, the stable voltage, capacitor voltage. So 3 ampere is going in this 10 ohm resistor and this 5 ohm resistance. So I just tried to find out, the current through this 5 ohm resistance. So 3 multiplied by 10, because I have to just find out the current here. So according to the C there, I will be just putting 10 ohms resistor in the numerator. 3 multiplied by 10 divided by 5 plus 10 is equal to 2 amperes. 2 ampere is the current. 2 amperes, and 2 amperes is the current, and multiplied by 5 ohms, that is 10 volts is the voltage of the capacitor. For finding out RTH at the terminals of the resistor, this will be open circuited. This in parallel with this is in parallel. The combination of parallel resistance 10 ohms and 5 ohms is in parallel with the capacitor. So 10 ohm in parallel with 5 ohms is 3.334. Tau is RC multiplied by 0.2, that farad with 3.3, and this is 0.134. If you just take inverse of it, 1 upon 0.134, that is 7.5. So you can easily write it. Putting in the values is 10 volts, this 10 volts here, and V of 0 was 20 volts, V at 0 20 volts, again 10 volts, V infinite, and then putting the tau value 1 upon tau, this is 1 upon tau, this minus 7.5. 7.5 is 1 upon tau. Alright, so this comes out, this is the answer, and this matches with the answer given in the book. So going further, this is the step response of RL. Here the voltage, instead of voltage, the current through the inductor is considered. So this is going to be the equation. For finding out these, we have to find out this, and the tau. Three things has to be found out, and that's what is is mentioned here. That we have to find out I at 0, I at a long time after the circuit has stabilized. Normally it is taken as 5 tau. So, and this is the time constant tau. Tau is given by L upon R. So I solve for you practice problem 7.12. So this is the circuit. This is the switch which goes on after at t is equal to 0. So I will just show you the resolution. 7.12 practice problem. Okay, this is the original circuit, and again I just tell you that you should not watch this video directly. You should just try to solve it on your own with copy and pencil. You just keep the PDF file of the textbook open on your screen, and see the practice problem from there, and try to solve it. And if you have any problem, you can just have this problem solved for you in this video. So normally what we do in our class, conventional class, is that I just flash the book on in front of you, and then just explain the concepts, and then ask you to solve the problems yourself, because you are the one which you have to go through the practice, not me. Although means I have just done these problems by myself, although I had the solution available, but I just wanted to have it more at hand, and it is a good feeling that you just explain something which you have written yourself. So I will just again like you to do these problems yourself. Okay, so this switch is off here. This switch is going off at time t is equal to 0, so that means it is on for time t less than 0. So this is on. This resistor is shorted, and this inductor is already considered a short circuit in a stable condition for a DC supply. This is a DC supply. Alright, so what current will pass through? It's a short circuit. The 10 ohm resistance is also short circuited, so this whole current will pass through this inductor, and I naught will become, that is I at time t is equal to 0, will become 6 amperes. And then this switch will go off, so this resistor will come in action in the circuit, and then we will find out the current. This is short circuit, so the current is 6 multiplied by 10 divided by 5 multiplied by 10, CDR, 4 amperes. RTH is the resistor at the terminals of the inductor, so this resistor in series with this resistor, that is 15 ohms, and this is the answer. Tau is L upon R, so L upon R is the tau, and then we have just used 0.1. Tau is 1 upon tau. This 10 is 1 upon tau. So R was 15, and thus tau was the inductor value divided by the resistor value, L upon R. Okay, next, how much time we already have just recorded? We are already on 13 minutes. So okay, so now I will just solve example number 7.13, and this example says that there are two switches. One switch is getting on, at t is equal to 2, switch 1 is closed. At t is equal to 0, the switch will get closed, but at t is equal to 4, this switch will be on. This will be closed at t is equal to 0.4. So we will just start solving this problem here. Although it's solved in your exam in your book, but I will be doing it on copy and pencil. So for time t is equal to 0, t is equal to 0 is less than t, and t is less than 4. So for a time slot of 0 to 4 seconds, this is the circuit. This switch is off, this switch is on, so this part is not here. From here we just find out I infinite, and already before it, for time t is equal to less than 0, the circuit, this supply is disconnected, this supply is disconnected, so the current through this inductor is 0 amperes. That's what I have mentioned here. And then I just find out time after time 0 to 0 less than 4 time less than 4, so it comes out to be the current through this inductor. So 40 divided by 6 plus 4, that is 10, is equal to 4 ampere, and the resistance at the terminals of the inductor is 4 plus 6 and 10 ohms, and tau becomes 0.5 L upon R. So the putting in the values of I infinite stable and I0 here, so it's 0 and 4, e raised to power minus 2, 1 upon tau is 2, this tau was 0.5, so 1 upon 0.5 becomes 2, and this is the response for slot of time 0 to 4 seconds. So now what we will have to do is, I just show you the next page, example 7.13 continued. So now I will have to just solve this for time t greater than 4. The circuit that has now is this switch has gone on, so these both supplies are involved in this circuit. So first of all we have to find out what is going to be the inductor current when we have just put this switch on. So for that we will have to do from the previous equation of putting in, this is the response time which we had last reached, so from the last page. So putting in the value of t is equal to 4, so it is 4 minus 4 upon e raised to power 8, this 2 multiplied by 8 minus, that's why it has come in the denominator. So this is going to be almost 0, it's a very big value, e raised to power 8, so 4 is the current, starting current. Then applying KCL at node P, where this I have just mentioned it as node P, and then writing the KCL. So what is going to be this current? Voltage of P, that is V, I have just given it the name of V of node P. So this voltage minus this voltage divide the value of the resistance. Next, this voltage minus this voltage divide by the value of the resistance, that is 2. This is step, and this is short circuit for a stable condition, so it means a voltage divided by this value of this resistance 6 is equal to 0. Solving it, we come out with the voltage V, the unknown variable, one equation, one variable, the voltage is 16.364, right? So if this is the voltage of this point, and I have to find out the current through this inductor, so inductor is a short circuit, consider short circuit for a stable condition, divided by voltage divided by 6 is equal to the current of the inductor, that is 2.727, right? 16.364 divided by 6, 2.727. For finding out the RTH at the terminals of the inductor, I just reduce the circuit, disconnecting all the supplies, disabling all the supplies, so it comes out to be 7.3364, and tau is equal to this. So here I have just continued these steps and putting in the values of I0. What was I0? I0, this is basically the current at time t is equal to 4 seconds, and that is this 4. So here I have this 4, and in finite we have already found out that is 2.727 again. And here I just want to explain a little bit about, because we have started a delayed this switch, so in the time response we have to just this delayed time delay has to be just included in. So minus t, normally it is just minus t upon tau, but here it is minus t minus 4 for the delay, and then tau is already calculated and putting in the values, and this is 1 upon tau, that's why this has been written in the numerator of the exponential. So this is the response. Again I have also solved one more example, end of the chapter problem for you to practice and understand, but definitely I will urge upon you not to see the watch the video directly, but rather you should watch it after you have already attempted the problem yourself, So I'm going to end of the chapter problems. Where is it? It is taking very long. Okay, I call it. Oh yes, this is it. I want to go to 6.5. 6.5. Oh, 6.5. Where is it? No, this 6.4. Where is it? 6.5. Yes, this is the 6.5. End of the chapter. So this input pulse is applied in this at this position, just a pulse. That means what we have to do? We have to find out the current I for all the time, t time greater than 0. So I will just show you the solution. Here it is. So first of all, the supply is not there at time t equal to less than 0. So there is nothing in the inductor. So I0 is 0. But once the supply has been connected, so what is going to be the stable current if this supply remains on for all the time? So this V supply is 10 volts. So 10 volts with the shorted this, it means the current of 10 divided by 5. The current will flow through this shorted path, that is 2 ampere. So RTH is 5 in parallel with 20, that is 4 ohms. This is 4 ohms, and then this L upon R is 2 upon 4 is 1 upon 2. Right. So but this is just a pulse, and it will not be remaining there for this circuit to get stabilized. So what will happen? This supply will be just disconnected after 1 second. So what we do is we just find out what will be the current at time t is equal to 1 second. So we just put the value of 1 here. 1 here. This was the response, and this is 1 second here. Putting in the value of 1 in place of t, it comes out that it is going to be 1.73 ampere at time t is equal to 1 second. Now there will be a natural response from this point on. So writing out the natural response from this is the initial current 1.73 multiplied by 2 raised to power. The time constant is going to remain same as in the previous circuit, because there is nothing happened in the time constant in the circuit. The only thing that has changed at time t equal to 1 second is the pulse has gone down. So from here to this point on, it will be just following the natural response. So I hope this was a good problem for you to grasp the concepts behind. The concepts are easy, but you have to just sit and then solve the problems and just focus on the videos next. Right, so inshallah we will be just doing next video on RLC circuits. Till then, wish you all the best wishes for you. Ma salama fi amanillah.